Hello everyone and welcome to our final video on angular projection. In this video, we discuss how we can derive the formula for horizontal range. Now, just to recap, in our previous videos, we have discussed what exactly is angular projection. We've derived a formula for the parabolic path. We derived formulas for maximum height and time of flight. And finally, we are here in the last video on angular projection, where we will discuss how can we find the formula for the horizontal range. Now, as you can see, I already have the formulae for maximum height and time of flight on the board, and this is just to remind you that we have been doing this in a series. So now let's begin with the idea of horizontal range. So the first question is, what exactly do you mean by horizontal range? And the answer is very simple. Horizontal range is nothing but the distance that the object covers from initial point of projection to the point where it comes back to the ground again. Now, the important thing to remember is that the range, is a horizontal distance. So, we are talking about horizontal distance from the point of projection to the point where it hits the ground again. This distance is what we call as horizontal range, or more commonly, it is also just known as range. The idea is to understand that range is the horizontal distance. And because it is a horizontal distance, I will use the kinematical equation only for the horizontal direction and get the answer for the horizontal range. Now, when we do that, we will use the information as available on this figure. Let me recap that for you. Initially, the object is projected with a velocity u, which is resolved into two components, u cos theta along the x direction and u sin theta along the y direction. Now, remember that the velocity along the x direction, that is u cos theta, does not change because there is no force acting along the x direction, and therefore the velocity of the object along the x or the horizontal direction is constant. The vertical velocity, on the other hand, changes and becomes 0 at the highest point. Now, using this information, I will try to find the formula for horizontal range. Now, clearly the horizontal range is the horizontal distance covered by the object with uniform velocity u cos theta in the time equal to total time of flight t. Now, you can see that they are calling this uniform velocity u cos theta because the velocity along the horizontal direction remains constant. Now, because this velocity remains constant, I can use the kinematical equation S is equal to ut plus half at square. Now, remember, I am using this equation for the horizontal direction, and in the horizontal direction there is no force and therefore there is no acceleration, and therefore this portion simply goes away, and what I will use is the formula S is equal to ut. Now, see how I use this in my given situation. I simply say that the displacement along the horizontal direction, that is from 0 to the point where it comes back down, is nothing but the horizontal range. So, I write r on the left hand side. Then I find out what is the velocity in this motion path. And in this motion path, my velocity is nothing but u cos theta, which is the uniform velocity during this path. Finally, I multiplied by the time taken, which in my case is the total time, which is nothing but the time of flight, and therefore I've written it as a capital T. Now you can see why I need this formula for capital T. The next thing what I'm going to do is simply put the value of capital T from this formula which we derived in a video previously. Now, once I calculate and reorder these terms, what I get is the final equation for the range, that is u square upon g 2 sin theta cos theta, and then I use the trigonometrical relation that 2 sin theta cos theta is sin 2 theta, and that gives me the final equation for range, that is r is equal to u square sin 2 theta by g. So this gives me the formula that I want, that is the formula for the horizontal range. The last thing that I want to do after saving this to my list of formulae is to make you understand how I can find the maximum horizontal range. To do that, take a careful look at this formula. In this formula, you will be able to see that given an initial speed, that is, once I have fixed my initial speed with which I will throw the object, the range only depends on this angle. So, if I want to find out the maximum horizontal range, if I want to maximize this right hand side, if u is fixed and g is fixed, the only thing I can make maximum is this sin 2 theta. And the maximum value of sin 2 theta is 1, as we all know. So, I say that if sin 2 theta is maximum, which is 1, it means that the sin 2 theta must be sin 90, because only sin 90 is 1. which means 2 theta must be 90, which means theta is 45. So to summarize, if theta was 45, this would be 2 into 45, that is 90, and sine 90 would be 1. And why have I said theta should be 45? Because I want to see what is the maximum value of r for a fixed u, and g is already fixed. So only this theta is in our control. And therefore from this I am making the conclusion that the maximum value of the range will be u square upon g. So if you want to find the maximum value of the horizontal range, it is u square by g. And when do you get the maximum value of the range? You get it when the angle is 45. And this idea, this information that to get the maximum horizontal range, you should throw your object at an angle of 45 degrees is well used in different kinds of sports, like the sports of javelin throw, where they throw the stick. They also use this idea in the long jump, because they know that for a given speed, if my angle is 45, I will get the maximum horizontal range, and the formula is u square by g. Now this completes all the formulae I want to talk about. This completes my discussion on angular projection. Thank you for watching this entire series. I hope this clarifies all your doubts on angular projection. So thank you for watching our series on angular projection. We make a lot more videos. If you like our channel, please subscribe. The link is below. You can also buy your very own target book by clicking on the link here. Please stay tuned for more videos and keep watching.